Okay, ji, Assalamu alaikum. We have started the effect of forces, and we had a discussion in the previous lesson. What could be the effect of forces? And today we are going to continue that how the forces, act on different objects, right? So if I consider, uh, let me take a picture of a car, right? Mhm. All right. So this picture, using this picture, we'll be able to observe different forces that are acting on it, right? So if the car is, moving, if it is moving, you know, if it is in motion, so what will happen when it is moving? So the two forces from the ground. So you can see the two forces from the ground, which are highlighted with the blue ones, right, in the picture. So they are normal force. Okay, normal force from the ground. Okay, normal force, right? And when the car is moving, so since I have already highlighted here, it is moving. So the force from the engine is in this direction. Force from engine, right? Force from engine. Okay. And the air particles will also strike on it. So they will be in opposite direction to the motion. Okay. So air resistance, we are going to call it air resistance, right? And there's a weight of the car. So that you can see here, it is highlighted with the green one. So this is the weight of the car. And it is always it always acts downward, weight of the car, weight of the object. Right, so this could be one possibility that how forces act on the object. If I have the object on an inclined surface, let me take another picture of the object placed on inclined surface, inclined plane, right? So how the forces are acting on it. Let's observe. All right, so let's understand the forces. The object, if the object is at rest, so let's assume the object is at rest now. Okay, if the object is at rest, so the from the surface, the upward force is going to be normal force. Okay, this is your normal force. This is acting upward from the from the surface, from the plane, right? And towards downward, there is a force that is called weight, as I have mentioned this in this picture as well. Okay, and if it tries to come down, so it's going that there is another force that is acting against the motion. So that's going to be the friction force. Okay, here is your friction force, right? Now, what happens when the object is moving upward, right? The same object, if I have the same object, right? Let me paste it again. So if I have the same object, let me call it in motion, right? Moving. The object is moving, right? And this time the object is moving in this direction, right? We are assuming the object is moving in this direction. Okay. So it must be lifted. It must be attached with some sort of a string or a cable, right? So anything has to be there so that it can be pulled in that direction. Okay, are you getting my point? So
Yeah,
so I'm going to consider this tension here. Okay, I'm going to consider the tension force here. Tension is the force that is, along the rope, along the string. Okay, and again, there's a weight that we have already learned this concept here. Over here, we have discussed this. So weight is the downward, okay, and towards the center of the earth. And here is the force that is acting upward from the, from the surface. So from the surface, the force acting upward, that's going to be the normal force, okay? So are you getting this concept? Yes,
yeah,
the
yeah,
force.
yeah.
Okay, against the motion, again, we are going to talk about the against the motion. There's a force that is going to be a friction force, okay? Right? So this is how the different forces act on different objects, okay? So let's assume if the object, let's assume the case of the object that is, uh, going inside the water. So let's assume that one, okay? All right, so let me take that one. One object that is, submerging. Okay. Okay, let's see this one. Right. I have taken the different picture. All right, but it can give the concept. Okay, so over here the object is, submerging. Okay, and we can apply the concept here. Um the force that is, that is acting downward, again, this is the weight of the body, right? And the force against, against the object from the water, so that's going to be up thrust. Okay, up thrust, right? And the object is, is staying still, right? The object is not moving. The object is not moving. Now let's assume another object that is in motion. Let's assume the object that is in motion. So let's see how, how the forces will act on it, right? It is in motion. I am considering this the red one, the red circle of the object that is in motion. Okay, so it is moving downward, right? It is moving downward, moving or coming downward. So what will happen? The how the forces are gonna, act. Uh, the weight is again downward, right? Okay, so weight is downward. And the upward force, that's gonna be up thrust, right? But there's another force since it is moving. So the water resistance will also, pull it up. There's a small force that's going to be the water resistance. Okay, that's going to be
Yeah.
the water resistance. So water resistance. Okay, so this is how, we have understood the concept of forces, that forces are acting on different objects. Okay, so we are going to talk uh about the laws of motion, right? Newton law of motion, that how the object, behaves when the unbalanced force acts on it. Okay, so we are going to talk about the second law of motion, right? The second law of motion, second second law of motion. All right, so the second law of motion states that if there is a resultant resultant force that must be unbalanced, okay? Because I have already spoke about the unbalanced forces, right, in the previous class, right? Unbalanced force, then the object will accelerate, right? Will accelerate in that direction, in that direction, right? Or we can say in the direction of the force, right? In the direction of the force. So this can be, this can be enhanced. The concept can be enhanced by taking this
Excuse me.
yeah, yes.
Can you give me 2 minutes?
Okay, sure. All right. So yes, we were discussing that how the forces are going to act, and how the object is going to behave when the force is going to is going to be applied. So you must have seen this. What are you observing here? That object is at rest, right? Okay. This object is at rest. So what is going to happen when I apply unbalanced force? This object is
Uh,
at rest. This object is at rest, right? This one. Okay. When I apply force, what's going to happen? It
it's gonna
starts
start.
moving. Yeah, it starts moving, right? Okay. And then it is going to accelerate. That means its speed is increasing, right? So this thing we have already had a discussion around this, right? And if the object is moving, right, and we apply opposite unbalanced force, so what will happen? The object will start decelerating. It is going to decrease the speed, and finally it comes to rest, right? Are you getting this
Yeah.
this way? Okay. And if the object is moving, right, and we apply the unbalanced force and in the direction of the motion, so what will happen? The body is going to speed up, right? And it will start moving with a greater speed, right?
Yeah.
Okay. So you can also, see here that if the object is moving, and we apply force perpendicular to the, to the direction of the motion. So you can see there's a change in direction, right? With the same speed. Now over here, we have not changed the speed, but the direction, right? So how the direction
Yeah.
is changed? Because there's an unbalanced force, right? So that it will come, it will, continue its motion, but the direction is going to be changed.
Yeah.
So acceleration can be done by changing the object's velocity. This is already done in the previous couple of classes, right? And change in velocity cause the object to start and speeding up, slowing down, stop, and changing direction, right? So this is the effect of forces. So what we can conclude that acceleration is directly proportional, right? So how can uh, could you believe that acceleration is directly proportional to the resultant force? It's directly proportional to the resultant force. Are you getting this concept or not?
Oh, sorry, I was muted.
Okay, so yes, acceleration is directly proportional. Are you understanding
Yeah.
directly proportional mean? Yeah.
Kind of. Yes,
Yeah, if I increase the force, so definitely the magnitude of the acceleration will also be increased. Clear?
okay. Yeah.
This is how the directly proportional uh, uh, you know relation is defined. Okay. So proportional to the resultant force. So what we can say that greater force
Great
will give,
acceleration.
yeah, will give greater acceleration. Okay. So acceleration is depending on force, right? And second thing is acceleration. What do you think? Acceleration is going to depend inversely to one of the factor here. If I increase the mass of the object, what will happen? Will the acceleration be greater or smaller? Keeping the force
Smaller.
constant, smaller. Okay.
Smaller.
Yeah, so acceleration is inversely proportional to the mass of object, right?
Mm.
Mass. Okay. So what we can say that greater the mass, greater
Uh,
mass,
Lower
smaller acceleration. Smaller
acceleration.
acceleration. Okay. Right. So mathematically we can write this formula that F is equals to ma. So that's going to be your F is the resultant force, right?
Yeah.
And here is mass, is, mass of the object, right? In kilogram. And your force is going to be in Newton, and acceleration is in meter per second square, right? So force is going to be the product of mass and acceleration, okay? Right?
Yeah.
I hope you have got this concept clear. So let's do one piece of example here. You have a piece of block or a object, right? And the mass of this object is 4 kilogram, right?
Yeah.
And the different forces are acting on it. One force, let's say, is 4 Newton, and one force is acting 8 Newton, right? Okay, and another force that is acting 30 Newton, right? Okay, so now we are going to find out the find the magnitude and direction. Okay, direction of the resultant. And I have already explained you how to find out the resultant force in the last class, right?
Yeah. Yeah.
And acceleration. Acceleration of 4 kilogram box. Okay, right? So how are you going to find out resultant force? Yes. Tell me how to find out the resultant force, Peter.
So first you have to find out the overall.
Okay,
So
resultant force. So
so
one
it's
force over here. What is the sum of force from left to right? 4 plus 8.
uh
4 plus 8. You can
12.
see this force is acting right side. Okay. So
Yeah.
12, and there's a force that
30.
is 30, right? So we are going to subtract it from, greater. Okay. So 30 minus 12, it's going to be 18, right?
20. Oh yeah, 18.
18. Okay. Right. And 18 to the left side, right? To the
Yeah.
left side. Okay. Now we can apply F is equals to ma. And because they are asking us to find out the acceleration, right? So can we make a subject, acceleration subject, right? F
Yes.
divided by m going to be a.
Equals.
Yeah,
So 18 divided by 4, which is 4.5.
yeah,
4.5 that m per second square. Meters per second square.
meter per second square. Is this clear now? Okay. So we have developed this concept, right? And direction of acceleration, yes, direction
Towards
towards the left,
the
right? Because along
yeah.
the direction of the force. Direction of acceleration is to the left side, right? Okay. Now let's talk about the third law of motion. It is not part of your syllabus, but if if you can make a make a link with the forces that forces always act in pairs. So yes, it becomes a law of motion, that is third law of motion, right? Newton's third law of motion. Okay. So third law of motion. Uh, so it states that when object, when one object exerts, when one object exerts a force on on an other object, then there are action and reaction take place, right? That means, what does this mean? That if one object is exerting force on another object, so another object, the second object will also exert force, right, as a reaction of that action, right? So what we can say that a pair of forces, forces always act in pairs, okay? Forces always act in pairs. That means when you, if you keep the, book, if you keep the book on the table, so what will you observe? Book on a table, right? Book on a table. So if I take this picture, let me take this one. Yeah, see, right? Oh my God, it's too big. All right. So the book, is kept on is placed on the table. So how you can, observe different forces? See, different forces are acting, right? The book is not coming down, the book is not going up. So that means there is a, balanced, right? There are the forces that are acting in pairs and they are balanced, right? They are equal in magnitude, they are opposite in direction. So if there is one action, if downward is the action, if this is action, right? So this is going to be the reaction, okay, from the surface. Okay, so we also call it normal reaction, right? Are you getting my point? Normal reaction,
Yeah.
yeah, that is acting upward. Okay, so the both forces are, balanced. So force on a book from the, from the table is the normal reaction, okay, or a reaction force. We also call it a reaction force, right? Reaction force. And the force on the table from the book due to the weight, right? It's the action, right? Action force,
Mm.
right? So now we have developed this concept that forces always act in pairs, right? So what we can say that equal in magnitude, yeah, equal in magnitudes, opposite in direction, right? And the third, act on different objects, right? Act on different objects, right? We cannot say that forces act on, one type of specific objects. They can act on different objects, okay? Even if I say that book, if placed at the surface of the earth, so it is being pulled by the, by the earth to its center, right? Okay.
Yeah.
All right. So if I take another example, like the forces from the rocket, right? Forces on rocket, right? I'll see this one. Right? So you can see the objects, another object that is here, that is rocket, right? It is going upward. So forces on the rocket from the burnt gases, that is the action, right? Okay, that is action. So this is uh forces. This is the upward force, right? Upward force, right? Okay, so force on the burnt gases. Burnt gases from the rocket. Yeah, so this is acting upward, and there's a force that is coming downward, right? That is coming downward. The forces on the rocket. Oh my God, I have done this. Actually, this way, this is the weight, and this weight is similar to what? So similar to the force on the rocket. Force on. Oh, I'm getting confused from the arrows, right? From the arrows. Weight is acting downward, so force must be, this force is against the reaction, right? This is going to be the action. Okay, so force on the burnt burnt gases, right, from the rocket. So when the gases are burnt, so a huge pressure is, created that pulls it upward, right? And this is how the rocket gets lifted. Okay. And there's a thrust, right? Uh, Against that weight, the thrust is formed, right? So that's going to be the upward, and it's the force on the rocket from where? It is what? It's the reaction, right? So what is the action? The action is caused by the burning of the gases, right? Action is
Yeah.
caused by the burning of the gases. So the rocket, is getting pulled upward. So the thrust is acting as a reaction. So force on the rocket from the burnt gases, right? From the burnt gases, right? So this is going to be the reaction, okay? Reaction force, right? I hope this makes sense, right? Okay.
Yeah.
Acha, if you're trying to balance yourself, right, with the wall, so force on the wall, you are trying to push the wall, right? This is your action, and what is going to be the reaction? The wall is also exerting force on you, right?
Yeah.
So force on the hand from the wall. From the wall, this is going to be the reaction, because a wall doesn't, wall is not taking interest, right? Unless you apply force first. So that is the action from your side, and the reaction is going to be from the wall, right?
Well,
Okay. After that, we have friction. Let's discuss friction. All right. Is this right? No, yeah, yes. Okay, so friction. Um, you must have, I have already, spoke about the friction in the case of motion, right? If the object is moving, so the opposite force acting on it. So friction is nothing but, if it is nothing but a force, right? Friction is a force that opposes the motion, right? Or movement, okay, of an object. right? So it acts in the direction opposite to the motion. So that's the same similar concept that I have already uh, shared with you. Friction is always, present almost everywhere, right? So it, slows down, or even stops moving objects, right? Yeah.
Yeah.
Uh, All right. So this actually happens. Why friction, happens? Because, when we move objects, right? When we rub the two surfaces, even we rub our hands, right? So what will you feel? There's a heat, right? So again,
Yeah.
the heat, is indicating that the force is there, right? And that is the friction. Okay. So this happens. This happens because friction converts the kinetic energy, because you are moving the object, right? Kinetic energy into thermal energy, right? And kinetic energy is the energy when the object moves, right? It's stored in it. And the thermal energy is the energy due to the heat, right? So if I say that there's an object on the surface, so if I'm trying to move this object to the left side, so the opposite, side, there would be a friction. Clear? Due to
Yeah.
the contact, right? Friction always opposes the motion, right? So if I have a car, right, on the surface, and here it is moving. So here is a driving force, or we can say the force from the engine, right? Force from the engine. And here's the friction. So the body is moving with a constant speed. So what we are going to say that the both forces are equal. Both forces are equal, friction and driving force. This is the balance condition, right? So the body is going to move with a constant speed. So inshallah, we will start from here in the next class, types of friction. Okay.
Yeah.
All right.